A while back, I did a video reviewing two premium or high-end rifle scopes. One was the Schmidt Bender PMII 4-16 power scope. The second was a Kahles K318i 3-18 power scope. And some of you had made a few comments that, hey, we'd like you to do a tracking test on those two scopes. And so since that time, I've been thinking about how to do that. You know, I thought about the whole tracking test, pretty straightforward. But creating a good video of that, not so straightforward. In fact, this was a very hard video to make it reasonable and for you to watch. So I'll give you a little caveat here. It's hard to get a lot of real good testing or tracking footage. So what I'm primarily going to be doing is talking about what I did to test the tracking capabilities of these two scopes and how you can do the same exact thing to test your scopes. I'll be telling you about how these two scopes, the Schmidt Bender and the Kahles scope, how they both fared in this tracking test. Now, before I even start talking about how to do a scope tracking test, let's talk about why a person would do a scope tracking test and what is a scope tracking test. Well, tracking on a scope compares the reticle adjustments or movements with the actual distance that scope's reticles are moving. In other words, if I come up 2 MOA or 2 mils, does my scope reticles actually move 2 MOA or 2 mils? Now, why is this even important? Well, it's important not so much for hunting applications, I guess, because, you know, when you zero your rifle for hunting, white-tailed deer rifle, mule deer rifle, whatever, when you get that rifle zeroed, that's about it. You're going to go out to the field, you're going to be hunting that game animal. There's the game animal. Maybe it's a little bit of a long shot. You hold it a little bit high, or you hold it a little bit this way, that way. That's about it. It's all the Kentucky windage. And so we don't really worry about scope tracking, even though we might be wrestling with that scope at the range while we're trying to zero it, because by golly, we just moved it up and now it didn't seem to move so much. You know, I've seen that sort of stuff happening. Well, that's sort of why we do a scope tracking test and why tracking is important. Let's think about precision, long range, or extreme long range shooting. And now I hope that you can see why a tracking test or a scope that tracks correctly, why that's important. If I'm going to be doing a 550-yard shot and I need to come up 47 clicks, well, and I dial that 47 clicks, I really want that scope to move 47 clicks, whether it's in a quarter MOA or tenth of a mil, and that shot had better be on target. First time, first shot right out of the barrel, better be on target. And that round will hit my target correctly, given that I have a well loaded round. My rounds are accurate, they're precise, so I have good ammunition. Number two, I do my part, or you do your part. And number three, we don't have any variable winds to have to deal with between me and that target 550 yards away. But a scope that tracks correctly in both elevation and windage, very important for, you know, really shooting long range, precision shooting, or the extreme long range shooting that is becoming more and more popular today. Now, the tracking test sounds pretty straightforward. If I turn it 2 mils or 2 MOA, my reticles had better move 2 mils or 2 MOA. But how do I do that? I mean, how do I measure that that scope actually moved that accordingly? Well, not too easy to do unless you have one of these. This is a scope tracking target. And notice we have values 1 through 8 along the y-axis and 1 through 5 along the x-axis. This is a mil-based tracking target, and this is exactly 1 mil here. This is 1 mil in both directions, in elevation and in windage. And so now what I need to do is I need to place this tracking target downrange. You know, you can actually shoot that tracking target, or you can just watch where the reticles are resting after you've made your adjustments. And actually, it is advantageous not to shoot, because when you're shooting, you are actually inserting one more level of potential error. That is shooter error, variability in the ammo, barrel heating effects, so on and so forth. So you're actually just fine watching where those reticles move to and where they end up resting. So I go out with my target and I put it downrange, and I start watching my scope as I'm turning the elevation and the turret. See how it's doing. Hold on. Mil and MOA are angular measures. And the question then is, at what range do I put my tracking target? That's a really good question. And so to test that before I even went out, what I did is I measured the distance here and here. I measured that in millimeters. And this, if this was 100 millimeters and 100 millimeters, then that would tell me that this target needs to be placed at 100 meters from my location. But this is not 100 millimeters. It is 91.4, a little over 91 millimeters in size. So that tells me that this target needs to be placed at 100 yards from my position. But exactly when I'm using my laser rangefinder to hit this target and see what my actual distance really is, and I'm using my Sig Sauer Kilo laser rangefinder, and I want to see 100.0 yards, where do I make that measurement from? Is it from the end of the muzzle? Is it from my eye? Nope. It is from the turret, the top or center of the turret of that rifle scope. From that location to the target should be precisely 100.0 yards from, apart in distance. In reality, if they're off by just a little bit, 100 point a little bit, not the end of the world. As long as we do not have it so different that we're essentially a click different on our scope. 1/10 of a mil, quarter of an MOA. As long as you are pretty darn close, really, to 100.0, you're fine. And you can then run that test. Now, the next thing that we need to do before we actually start running our test is to make sure that our target is leveled. This target needs to be leveled so that these lines along the horizontal lines, let's say, are level this way. For that because when I'm making my adjustments in the X and I'm making my adjustments along the Y, that needs to have the ability to track correctly. If this thing is crooked, there's no way it's going to track correctly, and you're going to have a very faulty results in your tracking test. So this thing needs to be leveled as close as you can get it. That's great. Not too terribly difficult to do that. You know, your entire target base doesn't need to be leveled. The target, tracking test target, is what needs to be leveled, those lines in it. So not too hard to do, but it needs to be done. With all of that taken care of, we can use any mill-based scope and put it through a series of movements and observe very carefully how well that scope's reticles track with the click adjustments that I've just made. Now, the hard part of this video was actually making the video. You see, what I found out is that as I'm trying to get some good footage through my scope, if I don't have that camera placed correctly as it's looking through the scope, it appears as if the reticles are not really in the right place. I started getting a lot of that shadowing, and if I move up to a real high power, which is how I actually did the test, then it became all the harder to do that. So we do want to make our test at high power. And that is really because, number one, at the high power on my Schmidt Bender, 16 power, 100 yards, 18 power on the Kahles scope, 100 yards, I can really see things on that tracking test target. I can see words, I can see graduations or gradations, I can see all that sort of stuff pretty darn well, and I can really see where that scope's reticles are resting. It's important also when you're doing this to make sure that you see a full sight picture. That means that your eye is in line correctly with that scope and you're not providing any parallax problems that would make it look like the scope's reticles are not in the right place. This took a long time to do this test. It was well over an hour that I spent doing this and was very careful and meticulous, as kind of is my norm, as I was doing this test, making sure that the scope reticles were read accurately, and I was making very good notes about the different movements I was putting into or clicking into that scope itself. So let's dig into the test itself. The first scope that I tested was my Kahles. That's a mill-based scope, 3 to 18 power. And what I did is I started at the 3 along the X, 8 along the Y, right up there. That's where I rested the scope. And then I came up 9 clicks, or 9/10 of a mil. Now you might be thinking, hold on, you just came up, but you're already at the top of that target. Yeah, well, here's how it works. When I come up, what I'm doing is, when you say come up, what you want to do is you want to bring your shot placement, your point of impact, up to be at the same place as the reticles. So what is really happening is you're not adjusting that barrel. There's no way that that scope and those little clicks you're doing right here, that it's somehow adjusting the barrel itself, making changes to the barrel. No, nothing's changing. That group is, those bullets are still going to the exact same place they always would have, whether you have a scope on or not. What you're doing is you're actually zeroing, right, or re-zeroing, bringing those reticles to be aligned and correct with the point of impact. So when I do a come up, I'm actually bringing my reticles down. When I move to the right, or I shift my reticles to the right to account for some wind, I'm actually moving my reticles to the left. Vice versa on the windage. So that's why I started in the center along the X value of 3 and on the top of that target tracking test at the 8 value along the Y. Confused? Let me demonstrate. This is my 6.5 Grendel with the Kahles 3 to 18 scope on it. And so let's say that this rifle is zeroed at 100 yards. Now, if I want to shoot that target at 550 yards, I'm going to dial my elevation up the necessary clicks, 46, 47 clicks, whatever, for 550 yard target. And as we know, as we just heard, we just talked about, that is going to move these reticles down. Therefore, when I bring this rifle up and I'm looking at that target, I am noticing that I need to come up. Now my reticles are on that target. And did you notice that originally the rifle was in a more or less very much horizontal plane? But as I made that adjustment, now the rifle is angled up. Now I actually have effected a true come up. The rifle came up, and the angle of departure has changed. Then I just watched as that reticles were moving as I was imparting clicks to the scope itself. So I then did a full 1 mil up, another 1/10 of a mil up. That gives us 2 mils in total. Then I moved her left 1.5 mils, 15 clicks. Then up to and left 1/2 mil. And sometimes some rifle scopes, when you're making adjustments in both the X and the Y, they don't do that well. That's why in that particular step I was purposely giving it both adjustments at the same time, and the Kahles did a great job there as well. Checkpoint F or Foxtrot, up 3 mils, Gulf or G, I went right 1.8 mils, so I'm crossing back over, went right 1.8 mils, and then the final test was a return to zero. Zero it all the way back on both the elevation and windage turrets, and then take a look at where my reticles were resting. And they had better be where? Right. They had better be back at the X of 3, Y of 8, darn near the top of that target. The Kahles scope did a great job all the way through, step by step. And what's also interesting is that the reticle subtensions in that scope aligned so nicely with what we're seeing right here. Really did a nice job. Very impressive scope. Well, my Schmidt Bender scope has MOA turrets. So you're probably thinking, well, I guess you can't do the test. No. We can still do the test. It just takes a little bit of math to let me do that test, and a little bit of careful choice or choosing of what those movements were going to be. So what I did for the Schmidt and Bender scope, or an MOA-based test, is I needed to find a few places where MOA clicks are essentially the same as my mil clicks. Now, I have a 1/4 MOA click adjustments on my Schmidt and Bender. I'm kind of accustomed also to the 1/10 of a mil. It's on my Kahles. However, if I give my Schmidt and Bender scope 1.75 MOA, that is 7 clicks, so 1/4 MOA, clicks is what these are. That is the same as 0.509 mil. That's really close. In fact, it's far less than a click different, and it's so small of a difference that I won't see a difference on my tracking test. I mean, I will not be able to see that with the resolution that we're looking at on this tracking test. Obviously, then 3.5 MOA is the same as 1.01 mil. 13.75 MOA is 4.00 mil. That's a good one to use. And then, of course, 7.25 MOA is equal to 2.109 mils. So I have lots of things I can do. Of course, that's true for both elevation and windage. So my checkpoints: checkpoint alpha, up 1.75 MOA. I started off at, again, x of 3, y of 8, and I should have ended up at an x of 3. I did not change windage, and a y of 7.5. Worked out wonderfully, worked out very, very well. Checkpoint Bravo, I moved it left 3.5 MOA. Charlie, 13.75 MOA up. Checkpoint Delta, moved her right 7.25 or 7.25 MOA, and then once again ripped those turrets back to 0, and the test was concluded. Did that Schmidt and Bender's reticles come right back to value of 3 along the x, value of 8 along the y? Yeah, you better believe it. Right on back, exactly where it should be. And so the Schmidt and Bender passed that test with flying colors as well. Now the Schmidt and Bender scope is kind of interesting because the reticles are mil. The turrets are MOA. And I also was very impressed that looking at the reticle subtensions and the way that those reticles are, wow, I mean, they really, really align perfectly well with these large blue lines here in the tracking test target. But we had one more scope that got included in this test. My son recently purchased a March optic. March is a premium optic coming out of Japan, probably the finest optics coming out of Japan, real good stuff. And his is an LPVO. It's a 1 to 8 power scope, exposed turrets, mil-based everything. And so in some ways it was like the Kahles in that I could click it wherever I wanted to go and just watch on that tracking target. But the fact that it only goes up to 8 power made it much more difficult to discern if I was off by a little bit. I put it through some paces, and then probably the biggest test with that March scope was when I ripped her back to 0, and once again that March scope came right back to where it should be. No problems observed at all with that March optic LPVO. So the overall results of my scope tracking test with 3 different premium scopes showed that all 3 of them passed with flying colors as I put them through the paces. I know that there are some other scopes out there that won't. I've had some problems with some other scopes, especially as I was zeroing those things. It was very obvious they don't track true. Sometimes they'll jump quite a bit with one click, and also they tend to want to move along an arc. That's a cheap way to build your reticle, your interior work, but it's out there, and you'll probably see that sort of stuff in some of the less expensive optics. And as I alluded to earlier, this was a time-intensive, or it is a time-intensive test. To do it well, to do it correctly, you really got to take your time and observe very carefully where those reticles are resting. Make sure you get a nice full eye picture or a good scope picture and before you make your reading, and then be very, very careful when you make that reading. Make sure everything is exactly where it should be, 100 yards downrange, leveled, so on and so forth. So it took me, as I said earlier, over an hour to do this test with just these 3 scopes. And it was a good test, though. I'm actually very happy that I did it. Gave me more confidence in my scopes. And I think with the notes that I just gave you, kind of those pointers, you'll be able to do the same thing. Now that tracking test target that I showed you, you can get those things from Action Target. That's where I bought mine. I bought a few of those things. I wasn't sure if I was going to do some live fire on these. Ended up not doing live fire, but you can certainly do this test yourself, especially with those good mill-based tracking targets that I already mentioned. Well, good luck to you in your test, and thanks for watching.